All right, good morning, Tigers. Or good afternoon, Tigers. I don't know. That's the beauty of online learning. You could be on this at midnight or at like noon. Okay, so we are moving on to lesson 1.2. So this is your video lesson that goes along with this. This should be your first completely at-home lesson. So we're going to do a couple of different things today. So let's go ahead. We're going to start with annotating our learning targets. So in this activity, we're going to use units to understand and interpret problems. We'll be able to choose and interpret an appropriate scale for a graph. We can interpret parts of an expression. And we can write an arithmetic sequence, or just a sequence. It doesn't have to be arithmetic. We'll get into that in a later unit. But we can write sequences that models a situation. Okay, so just a couple of things to point out. So the things that go along with this packet or this lesson, you have your guided video, which if I'm introducing that, like you're watching that, so boom. There is a Desmos activity that after this video, you should have a link to your Desmos activity. So we'll have that. This correlates with your practice assignment number 1 and spiral review number 1. And then the vocabulary is the same as the vocabulary from last time. All right, so your page is going to look a little bit different from mine. I've edited it since printing this, but that's okay because all the problems that we're going to do are the same. This originally was a group activity, so we're just going to cross through this. But we can actually discuss this. You can discuss this in the comments, or you can discuss this on Google Classroom. So task number 1, we're going to be looking at sequences with that are made out of toothpicks or triangles. So number 1, the following pattern was created with toothpicks. Discuss what you notice with your group. So we don't have groups, but we can go ahead and discuss what we notice right here. So in diagram 1, we have a triangle shape, and it's made with 3 toothpicks. In diagram number 2, on 1 we have 1 toothpick on each side. In diagram number 2, we increased to 2 toothpicks on each side. So instead of having 3 toothpicks to make up our triangle, we have 6. On diagram 3, we have 3 toothpicks on each side. We increase to a total of 9 toothpicks. Okay, there's some other things you may notice in this, and feel free to put that in the YouTube comments if we're watching on YouTube, or put it on, if we're watching this on Edpuzzle and a question pops up, put it there. I'm not sure exactly where we're going to be posting this because I'm filming these so far in advance, but go ahead, if it's just posted on Google Classroom, put comments there, so we can do that. All right, so number 2 says use the space below to sketch the next 2 diagrams in the pattern. I can't really do this as a group. So go ahead and sketch the next 2 diagrams. I'm going to ask that you pause the video and sketch it, and then check to see that you did it right. Okay, so I've sketched mine. Just had forewarning, I cannot draw, so it doesn't look very pretty, but you should have 4, 4, and 4. So a triangle made up of 4 toothpicks on each side, and on diagram 5, you should have a triangle made up of 5 toothpicks on each side. All right, so number 3 says complete the table based on what you've created. So for diagram 1, how many toothpicks were there? Well, there was 3 total. On diagram 2, there were 6. On diagram 3, there were 9. And then we can count for 4, but if we have 4, 4, and 4, we know that's 12. And 5, we should have 15. So I want to know, what do you notice is happening? Well, that's actually question number 4. Describe any numerical patterns you see in the data. So what are we noticing right now? How much are my number of toothpicks increasing by? So my toothpicks increase by 3 in each diagram. All right. You could tell me some other things like, well, for example, you could tell me how the diagram number and the number of toothpicks are related. You could tell me that each one of these is a multiple of 3, which is true. So there's a few other things you could tell me about this, but the most important is that the toothpicks are increasing by 3 in each diagram. All right, so let's move on to the second page. Okay. All right, so number 5 says write the number of toothpicks as a sequence. Does the sequence have a common difference, and if so, identify it? So remember, a sequence is just a list of numbers in a particular order. So why don't you go ahead, I'm going to ask that you pause the video, write your sequence, and identify the common difference. Okay, so just a quick check before I let you move on. And so we've got our sequence. Should just be 3, 6, 9, 12, 15, and then ... to show that this would continue. And our common difference is 3. Because if I were to take 6 and 3 and subtract, I should get a 3. If I take 9 and 6 and subtract, I get a 3. Or what we just identified in question number 5 was that our it's increasing by 3 each time. So that's our common difference. Okay. So I'm going to, again, ask that you do number 6 on your own. Go ahead and pause the video and try number 6, both parts A, B, and C. Okay, so I've gone ahead and written the answers down. There would be 21 toothpicks in the 7th diagram, 45 in the 15th, and 57 in the 19th. Now I want you to notice something. It says show your work or explain your process in words. The reason we ask that is because, remember, you get to use these notes on your quizzes. Or you get to, and if you don't get to use them on your quizzes, which I know Miss Means and I are allowing that, and I think Miss Flafflin is too, or Miss Flafflin, I'm sorry, I feel so bad that I can't pronounce things today. So I think all of our teachers are going to allow you to use notes, but in case for some reason you're not allowed to use notes, you want a study guide too. And yeah, having the answer is great, but when you go to study this, well, how did I get 21? If you just have the answer, that's not going to help you. So that's why we ask you to either show your work or explain in words. So how did I get 21 in the 7th diagram? Well, I know that it's increasing by 3. So I could just say I added 3 7 times, or I could say that 3 times 7 is 21. Okay, I did the same thing for the to get 45. I did 3 times 15 is 45. Well, how would I get the 57? I can't do 3 times 57. I know 3 times whatever my diagram number is equal to 57. So what's the opposite of multiplying? Dividing. I can divide by 3 and get that the 19th diagram would give me 57 toothpicks. Okay, so number 7 asks, how is the number of toothpicks related to the diagram number? So how can I take the diagram number and get the number of toothpicks? So let's just think about it. Actually, why don't I just look at the table instead of trying to recreate it? So diagram number 1 has 3 toothpicks. How do I get from 1 to 3? Well, I can multiply by 3. I can multiply 2 by 3 to get 6. I can multiply 3 by 3 to get 9. So all I'm doing is taking my diagram number and multiplying it by 3 to get this number. So we can say that the number of toothpicks is the diagram number let's take a minute here. If I had just one toothpick in the center each time that didn't change, don't draw this on yours, please. This is just theory. This would always be up by 1, right? So if that was the case, my toothpicks would still increase by 3 each time, but there'd always be that extra 1. So I'd have to add 1, and I would say the number of toothpicks is that diagram number times 3 plus 1. So giving you that little bit of information to help you maybe on the next couple. So just throwing that out there. It's not always going to be just something times a number. It could be something times a number plus a number, or something times a number minus a number. So just throwing that out there. Okay, so the number of toothpicks is the diagram number times 3. So we want to use the variable n to represent the diagram number. So n is the diagram number. And we want to write an expression so that I can determine the number of toothpicks in any diagram number. Okay, so I want to be able to figure out the number of toothpicks in the 400th diagram without me doing 3 plus 3 plus 3 plus 3 400 times. So what am I doing when you're adding 3 over and over again? Well, you're multiplying. If I go back to this, didn't I just do 3 times the diagram number to get a number? Or 3 times the diagram number, 3 times the diagram number. So if we're using n for the diagram number, we can just do 3n. And that's my expression. That's it. We're not going to put an equal sign because that would then make it an equation. So basically I can take whatever number I want, put it in for n, and that would give me the number of toothpicks for that diagram. Okay. Alright, so I am going to pause the video, or ask that you pause the video and try to graph and answer questions 10 and 11. So I want you to know something, because the first time I did it, I messed up. It says, show or explain with words how you can use the graph to confirm your answer from, this should be item 6A, not 7A. And this should be 6B, and this says use your expression. So just double check. It says graph and expression. Those are super important. So I'm going to ask you to pause the video and complete 9 through 11 for me. Okay, so let's go over 9 through 10. So the first thing I want you to notice on 9, before you can do anything, you have to scale your graph. This is what I personally take off the most points for in the course of my algebra class, because people don't scale this correctly. And if you don't scale correctly, what can end up happening is you can have a graph that should look like a curve but is now a line. Or if we don't scale consistently, like our line is steep and then flat and then steep, because it's not a consistent scale. So let's talk about this. What you should always have, we have 0 in the corner. This is the point 0, 0. If you notice, I did skip. So I had 2 blocks and then a 1, 2 blocks and then a 2. That's okay. You don't have to have each box represent 1 unit. And they don't have to be the same going this way and this way. They can be different. But the main point is that it's consistent the whole way through. So if I skip 2 blocks between 0 and 1, I better skip 2 blocks between 1 and 2 and 2 and 3 and 3 and 4. It has to be the exact same length between each number. If not, your graph is going to look jacked up. On the y-axis, I did go up by ones. I just wrote down every other number. What I see a lot of times is, oh, it goes up by 3. So 3, 6, 9, 12, and that's fine. But what I don't want you to do, if you have something that's not straight, like let's say your table looks like this, and this goes 2, 4, 8, 16, 32. if you were to do this, 2, 4, 8, 16, 32, it's going to look like a straight line when you graph it. Whereas if you did 2, 4, 6, 8, 10, 12, 14, 16. Whereas if you scaled it evenly, what's going to happen is it's going to go 2, 4, 8, 16. It's going to make a curve. So how you scale will determine the shape of your graph. And so that's why you have to always scale correctly, because this is what the graph should look like. It should be a curve. Here we just put our answers down and it made it a straight line, and that's not okay. So that's my PSA on scaling correctly. A lot of people are going to blow this off and be like, I don't need to know this today. But I don't want you to screw this up when we get into exponential graphs, which is in semester 2, but I see it all the time, and that's why I harp on it. Okay, so I scaled, and then I graphed my points. So we had diagram 1 had 3 toothpicks, diagram 2 had 6, diagram 3 had 9, so on and so forth. So all the points from my table are in pink here. All right, so number 10 said, show or explain with words how you can use the graph to confirm your answer from 6A. So 6A, my answer was that in the 7th diagram, I have 21 toothpicks. If I continue this linear trend, so if you look, between each point, I'm going up 3 units and over 2, up 3 units over 2, up 3 units over 2. You probably remember slope from 8th grade year. If I continue to follow this slope or to follow this linear trend, I will get to the point 721. So that's confirming that that is a viable answer or a viable point. All right, and and I did that in blue so you could see the difference. And then number 11 asked us to use the expression to confirm our answer for 6B. So in 6B, we said that diagram number 15 would have 45 toothpicks. So if I use my expression 3n and I change the n to my diagram number, which was 15, and multiply, I get 45. So I have confirmed it. And there we go. So let's see. I think this is, yes, so this is the end of task 1. Task 2 and 3 are a Desmos activity. Now you still have notes for this. I encourage you to complete your notes as you do the Desmos activity. Remember, you get to use these on your quiz. So blank notes aren't going to help you. So if you just do the Desmos activity, great, but you won't have those notes to help you, okay? You want a written record so that you can flip back and go, oh, this is how I did this. So I didn't make you do every single, like I took off some questions from the document and put them on Desmos, so you don't have to sketch things twice. You don't have to do some things twice because that gets redundant. But I did leave the most important questions on here so you could have your notes. So I hope that helps. If you have any questions, make sure to contact your teacher. If this is in YouTube, there should be a link that pops up in either the top left or top right corner that will take you to Desmos directly. You will need an access code. I know mine will be posted on Google Classroom. Your teachers will either have them, well, your teachers should have them also posted in Google Classroom, whoever's class you're in. So however your teacher delivers information to you in Google Classroom, check there for your Desmos access code. If you have any questions, please let me know, and I hope you guys have a good day, and I will talk to you soon. Bye!